Hi everyone, my name is Maryam Taeb and I'm a fourth-year PhD candidate at Florida State University. Today I would like to share with you the work that I did while at Apple with my colleagues Amanda Swearngin, Eldon Schoop, Regina Cheng, Jiang, and Jeff Nichols. This work is about AXNav, which is a system that takes accessibility tests written in natural language as its input and replaces them on the phone to produce a replayable, navigable video that a tester can use to pinpoint accessibility issues. With approximately 15% of the world's population with a disability, ensuring mobile app accessibility is essential, as many app functions and services are inaccessible to a significant number. Manual testing is a key method for evaluating the effectiveness of these assistive features. Apple's accessibility quality assurance teams conduct these tests following instructions that range from step-by-step protocols to more general guidelines, similar to the examples that you see on the screen. QA testers initiate the process by activating the accessibility feature being tested, for example, VoiceOver, and then manually executing a test like searching for a show or navigating to a particular screen to verify the expected behavior. With that motivation, we wanted to get a better understanding of two things first. What are some benefits of performing manual accessibility tests, and what barriers do testers face in doing so? We have formed a formative study and interviewed with 6 quality assurance testers at Apple. They all emphasized a key benefit of performing these tests manually is being able to explore the app from the perspective of a users of assistive technology. Some of them were also users of the features themselves, like VoiceOver. However, manually navigating and interpreting the test instructions is challenging and tedious. It can be also difficult to spot issues, especially if they are subtle. The vast scope of tests can also overwhelm testers within the development lifecycle. So, these challenges inspired us to create AXNav, a system that can interpret accessibility test instructions for QA testers. AXNav takes a manual accessibility test instruction written in natural language and leverages an LLM-based multi-agent planner and a live cloud device to replay the test on the device, which involves navigating through different UI elements. AXNav then creates a recorded video with that testers can easily navigate using chapters, view the behavior of the accessibility feature, and also identify the flags of potential accessibility issues. Now let's see how this works for the instructions podcast, VoiceOver, share an episode.
Murder mystery, true crime, weekly series updated July 5th, button, 8 news, the King Road killings.
As we watch the video, AXNav is breaking down and automating the test steps.
Listen now, account set, you might lock. The King Road killing, podcast back, button.
In this case, swiping through elements on the screen through the VoiceOver service.
Back, but follow, more, button. Follow show, button. Follow, share show, dismiss context method King Road killings, an Idaho murder mystery.
The ping markers show where the agent is interacting on each step.
The King Road ABC close, airdrop, messages, but text field is editing, character mode, insertion pointed start.
After AXNav plays through the steps once, it replays them again with the feature off, so that QA testers can verify the behavior still works after toggling off the feature. The chapters on the side of the video are showing the steps taken by the agent as well. Here you can see where VoiceOver was activated and deactivated, and the steps the system took to navigate to the messages screen. Now, let's see how AXNav works. AXNav was designed to test 4 kinds of accessibility features that reflected the needs of QA testers from our formative study. AXNav provisions a remote cloud iOS device and prepares it into the necessary state for executing the test. The UI elements on the screen are detected via a pixel-based technique and formatted. The multi-agent planner initiates the planning of steps needed to replicate the test and then carries them out on the device. Now, in more detail, AXNav first connects to a live device over VNC and uses the screen recognition framework to retrieve the state of the device for the navigation system. It then employs an LLM-based multi-agent planner for UI navigation, where the planner creates and updates a multi-step plan based on the app's current state. For each step, the action agent selects an action tied to a UI element. The evaluation agent considers the test goal, the plan, the action taken, and UI changes before and after execution to assess success. Actions defined by the LLM are executed through a library which installs a custom app to bridge with the OS APIs, enabling interaction via assistive technologies and screen recording. For VoiceOver tests, it performs actions mimicking VoiceOver users' navigation, and for non-VoiceOver tests, it simulates clicks, swipes, and text input. The library also handles turning off the accessibility feature and renavigates once the target is reached. As it operates, AXNav records the app's screen, applies heuristics to the target view, annotating video frames with visual test outcomes like dynamic type and button shapes. For VoiceOver, it assesses specific issues like loop bugs and missing elements during activation commands. The final video is then accelerated and segmented into chapters. To evaluate AXNav's performance on replaying the test instructions, we have first classified test instructions complexity into two categories. Easy, where single-step regular expression-based retrieval matches the right UI element and action, and hard, involving structured problem-solving or open-loop planning across multiple screens, requiring the planner agent to adapt its strategy and action and evaluation agents to ensure successful multi-step task completion. We then evaluated AXNav's navigation on those test instructions using two datasets, one comprising 5 randomly selected apps from the top 100 free apps on the Apple App Store, for which we created and QA expert validated 4 manual accessibility tests, achieving a 70% success replay rate. The second dataset consisted of real accessibility tests by our accessibility quality assurance teams for the first-party apps, with an 85% successful replay rate using AXNav. Additionally, AXNav identified significant accessibility issues in the free app dataset, with only a 15% pass rate after video review, indicating 85% of them contain accessibility bugs. After we built AXNav, we also evaluated it by conducting 10 one-to-one interview-based study sessions with QA testers where we showed them AXNav's videos for 3 types of tests and had them to think aloud and let us know if they spotted any issues. We also asked them to provide 5-point Likert scale ratings on 1, similarity to how they would perform the test manually, and 2, usefulness in their workflow, and then gathered their feedback. Participants found the system navigated the tests similar to how they would manually, giving high similarity ratings of over 4 out of 5 for all test types. Participant 3 said, "My mind is blown that it was able to find that shared button buried within that actions menu." Participants did find some differences though between the videos and their manual process. To test dynamic text, they would use the control center to resize text without relaunching the app, while AXNav relaunched the app in between each text size change. Participants would also take more exploratory paths through the app rather than directly executing the steps like AXNav. The participants also thought the heuristics could help them spot issues more easily, which AXNav also annotates in impacted frames and in the chapter labels. Some, such as participant 10, saw them as flags to take a look at rather than giving a definitive answer. All participants found actual bugs in these apps aided by these heuristics. Even though heuristics might outperform most human testers in button shape, since it could be subjective for a human tester to determine what consists of a button shape, one risk of heuristics is of over-reliance on them, pointed out by a couple of participants. Since inexperienced testers may see them and file bugs even if they are false positives, systems like AXNav should try to mitigate this risk in the future. Participants recommended making heuristics more understandable by integrating human-readable descriptions and annotations directly into the videos, separate from regular chapters, and including a dashboard or summary of errors for easier review. Finally, several of the testers would like to integrate this into their workflows, and one participant rated the system a 5 million out of 5 for potential. Even with its current limitation, they would find it massively powerful to be able to give it simple steps and have it to do anything. QA testers also thought AXNav could be useful in their current workflows. AXNav could automate test planning steps like setting up the device and going through the test, saving testers the effort of writing tests and navigation logic to author test cases. Testers would use it mostly to complement to their manual tests to see if it could find things they couldn't, or would use it for lower risk features to give them more time to carefully test higher risk features themselves. AXNav's output videos and screenshots could accelerate their bug filing. It could also help novice developers to better understand the behaviors of accessibility features. We look forward to pursuing these use cases in the future work as part of a larger work. Thank you for listening to our talk. We are happy to take any questions.